Hello again. My name is Jacob Stinson, and if you've seen my videos so far, you know I'm currently preparing to take exam P, and this video will be dealing with exam problem number 163 from the SOA sample problems, and it's dealing with continuity correction, so let's get right into it. So let me pull up the exam P problems. Let's go to our problem. Okay, so we're going to be doing 163. So if you need to pause the video to write the question down, I strongly recommend it. So this question says, a student takes a multiple choice test with 40 questions. The probability that the student answers a given question correctly is 0.5, independent of all other questions. The probability that the student answers more than n questions correctly is greater than 0.10, and the probability that the student answers more than n plus 1 questions correctly is less than 0.1. Calculate n using a normal approximation with the continuity correction. So if you do not remember how to do continuity corrections, I would strongly recommend reviewing on that. I will go over that as we go on for this specific problem, but it might be best if you review that on your own. So let's get to it. So we know that there are 40 questions going to be asked for this test for the student. So let me change back to my regular black. So we know that there are going to be 40 questions on this test, and I'm going to let C be the number of questions correct for the student. Okay, so we know that this is a binomial distribution because we're having n number, which is 40, with x number of successes. That's the definition of a binomial distribution. So C is binomial with n equal 40 and P is 0.5, where we're told the questions are mutually independent with a 0.5 probability of success. So we just know from knowing from the binomial distribution that the expectation of C will be 20, and then the variance of C will be 10, because we know that 40 times 0.5 is 20, and then 20 times 0.5 is 10. So the key here is knowing how to apply the continuity correction. So when you're doing a continuity correction, it's when you want to change a binomial distribution and use the normal approximation to solve the problem. So for our for the first scenario, so we know that from the problem that we have probability n is greater than, sorry, not n. We know that the probability of C greater than n is, let's see, is greater than 0.1, and then probability C is greater than n plus 1 is less than 0.1. So we'll come back to this later in the solution video. So we'll come back to that. But for the continuity correction part of it, for this probability C is greater than n, we have to do probability C is greater than n plus 0.5. And that just comes from knowing how to apply the continuity correction. So now we'll use the normal approximation. So we know that this is equal to probability that C minus mu over the square root of the variance of C is greater than n plus 0.5 minus 20 over the square root of 10. That's applying what we know from the normal distribution. So then this equals probability Z is greater than n minus 19.5 over the square root of 10, which is equal to 1 minus the probability Z is less than n minus 19.5 divided by the square root of 10. If you want to write that in our shorthand notation, it's equal to this. All right, and then for the n+1 case, we know that the probability of C greater than n+1, we have to add that 0.5 for the continuity correction. This equals probability C minus mu over square root of variance of C. This is the same way of writing sigma, but I'm just going to write square root of variance of C, square root of the variance of C. This is greater than, let's see, n plus 1.5 minus 20 over the square root of 10. This equals probability Z is greater than n minus 18.5 divided by the square root of 10. Kind of similar as the last one we did, and this is just going to be equal to 1 minus this notation of n minus 18.5 divided by square root of 10. So we've done the continuity corrections. Now we've got to figure out what n is, okay? That's our goal. We want to find out what n is. So we're going to use these two inequalities that I said we would get back to later to solve for n. So for this one, we're going to say that the probability, let's kind of move over to the left side here. We're going to move over to the left side. So the probability that C is greater than n is greater than 0.1. Well, we know that this right here is equal to the probability C is greater than n. Okay, so this implies this is 1 minus n minus 19.5 divided by square root of 10. It's greater than 0.1. Do a little rearranging. This is equal to 0.9 is greater than, I'm so sorry, I do not know what they call this. So we're just going to keep going here. All right. And then we need to find the inverse z-score of 0.9, which is 1.28. If you look at your table, this is equal to the inverse of 0.9. And then we're able to say this is greater than just n minus 19.5 over square root of 10. And then this implies n is, this implies that 23.55 is greater than n. Okay. For the second one over here, we know that the probability that, I'm running out of room here, C is greater than n+1 is less than 0.1. That equals, you know what, let's just go to the next page. So I'll bring this 23.55 greater than n with us. Let me open a new page. So we found the first one. We know 23.55 is greater than n, and then we're going to do the probability that C is greater than n+1 less than 0.1 now. So probability that C is greater than n+1 is less than 0.1 from what we've already found this. So we know that this is equal to 1 minus n minus 18.5 divided by square root of 10. It's less than 0.1. Let's rearrange it a little bit into 0.9 is less than this, n minus 18.5 divided by square root of 10. We know that the inverse z-score of 0.9 is 1.28, and then n minus 18.5 divided by square root of 10, and then this implies that 22.54 is less than n. So we have this new interval that n is between 22.54 and 23.55. So clearly n is equal to 23. All right. So this completes another solution video. Yeah, this is a pretty difficult problem, I would say. This is definitely one I would recommend working out a few times to understand. I know I'll be reworking this one for sure. As always, like this video. I've had trouble enabling the comments, so I will attempt to fix that issue, but always like and subscribe, and thanks for watching.